Like, share, subscribe and click on bell icon to get notifications from Vishwavidyalay. Please contact for online tuitions through our email address, that is vishwavidyalay@gmail.com. Welcome to Vishwavidyalay online learning platform. Good morning to everybody. In today's class, we will learn about Dalton's atomic theory. John Dalton, an English chemist, proposed the atomic theory of matter in 1803 to 1808. His theory was the first scientific explanation of the nature of matter based on experiments. It explained chemical combination and laws of chemical reactions such as the law of conservation of mass, the law of definite proportions and law of multiple proportions. Main postulates of Dalton's atomic theory. Matter is made up of tiny, indivisible particles called atoms. Atoms are the fundamental building blocks of matter. They cannot be created, destroyed or subdivided. Atoms of a given element are identical in mass, size and other properties. For example, all oxygen atoms are exactly alike in every respect. Atoms of different elements differ in mass, size and properties. Atoms combine in simple whole number ratios to form compounds. For example, hydrogen plus oxygen gives rise to water in the ratio 2:1. This explains why compounds have a fixed composition. Atoms cannot be created or destroyed in a chemical reaction. Reactions are simply rearrangements of atoms. This supported Lavoisier's law of conservation of mass. Chemical reactions involve the rearrangement of atoms. Atoms combine, separate or rearrange to form new substances, but the atoms themselves remain unchanged. Now let us see the examples of Dalton's atomic theory. Matter is made of indivisible atoms. Example, a piece of gold can be cut into very small parts, but each part still contains gold atoms that cannot be further divided by ordinary means. Atoms of the same element are identical. For example, all oxygen atoms in nature have the same properties like mass and chemical behavior. An oxygen atom in water is identical to an oxygen atom in carbon dioxide. Atoms of different elements are different. For example, a hydrogen atom is different from an oxygen atom in mass and properties. That's why H and O combine to form water, but not pure hydrogen or oxygen again. Atoms combine in simple whole number ratios. For example, in the reaction 2H2 plus O2 gives rise to 2H2O. The same atoms of hydrogen and oxygen are just rearranged to form water. No new atom is created or destroyed. Atoms cannot be created or destroyed in chemical reactions. For example, in the reaction 2H2 plus O2 gives rise to 2H2O. The same atoms of hydrogen and oxygen are just rearranged to form water. No new atom is created or destroyed. Atoms of different elements combine to form compounds. For example, sodium plus chlorine gives rise to sodium chloride. Now let us see another example. Carbon plus oxygen gives rise to carbon dioxide. Now let us see the real life examples of Dalton's atomic theory. Table salt. According to Dalton, atoms of sodium and chlorine combine in a 1:1 whole number ratio to form sodium chloride. Water. Every drop of water has the same composition. 2 atoms of hydrogen plus 1 atom of oxygen. This matches Dalton's idea that atoms combine in fixed proportions. Sugar. All sugar molecules contain exactly 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. No matter where sugar comes from, the composition is identical, which supports Dalton's idea that atoms of the same element are identical. Carbon dioxide. When we breathe out, we release carbon dioxide. Each molecule has one atom of carbon plus two atoms of oxygen, showing Dalton's whole number ratios law. Rusting of iron. When iron rusts, iron atoms combine with oxygen atoms in a fixed ratio to form iron oxide. Atoms are neither destroyed nor created, only rearranged. Cooking with gas. LPG or natural gas mainly contains methane. Each methane molecule is always made of one carbon atom plus four hydrogen atoms, again showing Dalton's fixed composition rule. Importance of Dalton's atomic theory. It gave a scientific explanation of the nature of matter. It explained laws of chemical combination. It laid the foundation of modern chemistry. It introduced the concept of atoms as building blocks. Limitations of Dalton's atomic theory. Indivisibility of atoms is incorrect. Later discoveries showed that atoms are divisible into subatomic particles. Atoms of the same element are not always identical. Isotopes have the same element but different masses. Atoms of different elements can be similar in mass. Isobars have the same mass but are different elements. It did not explain how and why atoms bond. The theory could not account for the structure of atoms or the nature of chemical bonds. Dalton's atomic theory was the first scientific model of matter. It proposed that matter consists of indivisible atoms identical for each element, combining in simple ratios to form compounds. Though many of his postulates were later modified, it paved the way of modern atomic structure theories. Thank you so much for watching this video. Please subscribe through this YouTube link. Thank you so much.